All right, welcome everybody. This is 8.4. We're solving logarithmic equations. So last time we did some solving with exponential functions or equations. So we're doing something very similar, kind of the same orders, but instead we're using like the opposite inverse. So like before we used logs to get the bases away, today we're going to use bases to get rid of the logs. Okay, it's basically the same, just kind of looking at it a different way. Okay, so just a quick reminder of what we did last time is that, like I said, if we have a base and we want to get the x by itself, we could use its opposite. So log base 3 on both sides, and we would get x equals log base 3 of 81. For these, I'm just asking you to rearrange them, so like we did in our last unit. So you don't need to actually evaluate these ones, okay? If we look at this one, we could use a log base 4 to get rid of that base. So x equals log base 4 of 27, okay? So usually it'll take you maybe a little bit more steps, but again, what we're using is the opposites of a base is a log, and the opposite of a log is its base. So if we look at this example, if we're trying to get rid of this log, we would want to use the base of 36. Again, when we do that, it makes the original expressions their exponents. So we end up getting 36 to the 1/2. And that's what x is. Okay? Let's try one more like that. So what would get rid of the log would be its base. And we'd get x equals 17 to the 0. And again, I'm not asking you to simplify it here, but if you wanted to, you would end up just getting 1. So I think it's kind of important to remember that. All right, so let's do one more example that was maybe a little more difficult like last time, and then we'll get into the new stuff. So again, kind of thinking of PEMDAS backwards, we'll want to get rid of that 5 first. So we would divide both sides by 5. So we get 2 to the 7 minus x equals 8. Next, we'd want to get rid of the base. So we would do log base 2 on both sides. Next, we'd want to get rid of that constant. So we're kind of like, basically, once we get rid of the base, we restart, PEMDAS backwards. So we would add or subtract first. So now we have negative x equals, and here, if you wanted to, we could simplify that to log base 2 of 8. Again, when it's just saying 2 to what power is 8. So that exponent would have to be a 3. And that would end up giving negative 4. And then to finish that up, we could just divide both sides by negative 1. Okay, so there's a quick review of what we did last time, because we're going to be doing things that are very similar to that. So if you'll just kind of come to the next page, when we are solving log equations, oftentimes we'll need to use some of the rules that we learned at the beginning of the unit. So here, if we see a times log b, then we can rearrange that to be log b to the a. So again, we're basically taking that coefficient and we can have it as an exponent, and those are equivalent. Okay? If we're adding logs, then we can multiply their arguments. So log of a times b. And if we're subtracting logs, then we can divide those arguments. Okay, so it's kind of similar to those exponent rules, just kind of going the opposite direction. When we add, we multiply. When we subtract, we divide. Okay? All right, and then you can have a look at that if you feel like that's helpful. There's little hints here and there to help you get going. Okay? So let's go and try some of these problems. If we're trying to solve for x, again, kind of think PEMDAS backwards. We will want to get rid of the logs as soon as we have a single log. So we want to get rid of that 8 first. So we get log base 6 of x equals -1. And then now we can get rid of that log. We'll do base 6 on both sides. So x equals 6 to the -1. So on your homework, it's going to let you turn in, or what am I trying to say? You can put in any answer as long as it's equivalent. So you could put that as your answer. You could also write it as 1/6. We learned that a negative exponent, we can do its reciprocal. Okay, if you cross the line, you change the sign. Okay, or we could write it as a decimal. So we could just type into our calculator 1 divides 6. Most people didn't do this, but that's fine. And I would want you to round to 2 decimals. So that would be 0.17. Okay, so any of those would be okay when you submit your homework, okay, or your problems. All right, let's give this one a try. So we have a single log on both sides, which means we can just get rid of those by doing their opposite. So we do base 10, base 10. Those would just cancel, so we'd get 3x minus 6 is equal to 2x minus 1. And then maybe subtract 2x to this side. And we could add 6 to this side. So these would just cancel. And we'd get x equals 5. Okay. One thing we need to be aware of is that you can have extraneous solutions here. So an extraneous solution is whenever the argument would be 0. So if we plugged 5 in here, we'd get 3 times 5 minus 6. Like if that's our solution and we plug that in, it can't be 0 or negative. So here, I think we'd end up getting 15 minus 6 would be 9. So 9 is greater than 0. So we're good to go. And if we plugged it into here, we'd get 2 times 5 minus 1, still gives us 9, which it kind of has to be since these two are equations equal to each other, sorry. Okay, so just be aware of that. If you ever get an answer and you're fairly certain that you have your right solution, but it tells you it's wrong, you might want to check and see if you have an extraneous solution. Okay, I'll give you an example of that right here. All right, so one of our rules, if we have a coefficient, we can get rid of it and write it as an exponent. Okay, and then now we could get rid of the logs because there's a log on both sides. Base 4, those will just cancel. So we get x squared equals 81. So this is, what we have now is a quadratic, which means we should have 2 solutions. To solve, we would square root both sides. But just remember, when we solve using square roots, we always end up getting a plus or minus. So we would get x equals 9 and -9. Okay. So if we go back to the original equation before we did anything, so maybe I'll just erase that for now just so we can see it. If we plug 9 in here, that's great, right? That's a positive number. But if we take this -9, that can't work, right? That is an extraneous solution. Okay. But on your homework, there's only going to be a spot for your actual solutions. So we would just enter 9. Okay. But if you plugged in 9, -9, then you would lose some points. Okay. All right. Try a couple more. This one's a little easier. We've got to remember what's the opposite of a natural log. Well, that's an e. So we've got 5 minus 2x. And here it might be helpful to remember that anything to the 0 is 1, right? If not, you could put it into your calculator and check. Then we would subtract. And then we would divide. So we would get x equals 2. Again, if we plug 2 in here, we would get 5 minus 4, which is just fine. All right, we're not going to do all of these here. I think we're going to maybe do 4 of the 6. Some of the others are very similar to what we've done, so if you need to look at that, I have it filled in on the notes. All right, so here's the other type of rules that we've covered. If we add, then we multiply. So here we're adding logs, okay, and I should be careful. It's like if you had log of 2 plus 4, like we're not actually going to multiply. It's only when we're adding logs, right? Okay, so here we would get natural log of 2x times x, and 2x times x would be 2x squared. And then we would get rid of the natural log. And then we would maybe divide both sides by 2. Okay, a little note here is that you wouldn't want to evaluate that e squared because you would have to round. And if you round something that's not at the very end, then that error, that rounding error, propagates. It means it gets worse. So you got to be careful. Make sure if you're using e, then keep it in until the very end. Okay? All right, so we've got x squared equals e squared over 2. And then our last thing would be to square root. And if we look at the plus or minus, like we'll have plus or minus. Again, we can't do the minus because then we would get a negative in either of these natural logs. Okay, so we'll just use the positive. We'll put that into your, enter it as your answer, or you can write it as a decimal. So if it's helpful, just you got to remember how to find e on your calculator. Okay, for those that did do that, let me do that really quick so we can check your work if you want to do it this way. Almost there. There we go. So I end up getting 1.92. So that you could put that as your answer. Either would be great. All right. Next, here's another example. It just looks a little different because we have like a binomial here. So again, when we add logs, what do? We multiply. So this would be log of 2 times x and 2 times negative 3. So we're multiplying. It's the distributor property, right? So we'd have 2x minus 6. Then we'd get rid of that log. Again, it's a base 10. And 10 to the 1 is just 10. And then we would add 6 and then divide. Okay. All right. Next off, now we have an example where we're subtracting logs. So if we subtract logs, that means that we're dividing. So we would have log of 6 over 3x is equal to negative 2. Now we have a log by itself. We can get rid of it by doing its base. And now look at this, 10 to the negative 2. So remember, 10 squared is 100. And if we have a negative exponent, then we can do its reciprocal. So 1 over 100. So if we ever have x in the denominator, I think the easiest way is to cross multiply. You could do it differently if you'd like, but when we cross multiply, we end up multiplying across like that. So we would get 3x equals 600. And then we would divide. So cross multiply, divide. Okay. Any questions on that? Come and let me know. All right, last example. So again, we have an example where we're subtracting. So we will divide. So natural log of x minus 2 all over 9. So this one's a little different because we have a natural log on both sides. So those will just cancel out. So x minus 2 over 9 equals 8. So then we would get rid of the denominator, multiply both sides by 9. and then finish up by adding 2. Okay, so again, kind of follow those rules. So if we ever, the first thing we would always want to do is see if there's any adding or subtracting between logs or any coefficients. If there's any of those, always take care of those first. Usually that will reduce things to a single log. And then once we've taken care of those logs by doing their bases, canceling those out, and then we kind of just follow PEMDAS. We do any adding or subtracting, and then multiplying or dividing. Okay. The reason why we divided here first is because this is like a parenthesis, and we would need to get rid of what's being divided so that we could start doing this stuff on the top. So just kind of keep that in mind. All right, last thing, you're going to see something similarly of this when you get near to the end of one of your problems. So just a reminder, when we have x squared, how do we get rid of an x squared? Well, we square root. But what if it's a cube, like x to the third? Well, then we do a cubed root on both sides. Sorry, I should probably be doing those on both sides. All right, so if you had an exponent of any number, then we could do that same number as your type of root. Okay, so like this very last one, we would do this, the 11th root. That would cancel, and we could just enter this as your answer for your homework, or you could evaluate it. Okay, your calculator, most of the calculators have something that looks something like this. You might have to look for a little bit to figure it out, but if you want to evaluate it, usually there's a button that looks something like that. Okay, or for the TIs, I think you go to Math and go down a little bit, and you should be able to see it. Okay, all right. Well, good luck. Let me know if you have any other questions. This is just additional practice. I have it filled in on the notes. Some of these are a little more challenging, so you might need, if you need any help, come and talk to me. But again, you do not need to do this. This is just more like extra practice. Okay? All right, we'll see you later.